Hello everyone, my name is Timothy Lee Grant, and look at the date, it is December 25th, Christmas! So, today, welcome to this wonderful Christmas edition of LeetCode. Let's grind some LeetCode today. So, I decided to switch up my strategy a little bit. Recently, I have been doing depth first search, and I have just been focusing on it. I've been doing problems after problems after problems with the idea of okay, eventually I am going to be somewhat comfortable with this idea of depth first search. But I want to add a little bit of extra complexity to my plan, which I think will actually be fairly beneficial going forward in my LeetCode journey, which is kind of the learn and forget method. So I feel like I've gotten to the point with depth first search that I kind of understand it. I'm all right at it. I can solve some mediums. I can't solve other mediums, right? I got to a position where I'm like, okay, I feel okay. But now I'm going to put that one aside for a little bit, go to a different topic, learn that topic. Okay, and then once I feel a little bit more comfortable with that topic, great. Then I can go back to depth first search. So, kind of implementing that learn and forget. So, today we are going to be doing a different topic, which is heaps. And I have not I tried to do heaps a while ago on a website called LeetCode. So I remember doing heaps like 4 or 5 months ago, but I have completely forgotten. So I am now essentially seeing this for the first time, and I'm probably going to need to refresh myself on a lot of the functionalities of heap. So this is kind of an introduction video, an introductory question. And so, gonna get us started on the heap journey. So let's all of these are like mediums and hards. Are there any like easies that are not? Okay, so here's an easy. The k weakest rows in a matrix. Okay. Cheers. Nice latte coffee. Okay, so 1337. The k weakest rows in a matrix. You are given an m by n binary matrix mat of ones representing soldiers and zeros representing civilians. The soldiers are positioned in front of the civilians. Okay? That is, all ones will appear to the left of all the zeros in each row. Okay? So we have ones and we have zeros. Ones represent soldiers, zeros represent civilians, and they are going to be arranged in some way, in some rule. Okay, cool. A row I is weaker than a row J if one of the following is true. Okay, so now we are given rules by which we are able to determine if one row, so this way, horizontal, one row is weaker than another row. So some comparison metric which we're given. Okay, cool. The number of soldiers in row I is less than the number of soldiers in row J. So if there's less soldiers than in one of the rows, the one that has the least amount of soldiers is the weakest. Okay. Both rows have the same number of soldiers and I is less than J. So, okay, so if there's a tie, if we have the same amount of soldiers in both rows, we look at the index and both rows have the same number of soldiers and I is less than J. Okay, so I is indexing one row and J is indexing another row. So I guess this one means that the index which is higher is going to be stronger when breaking a tie. Okay. So we're given this example. We have 1, 1, so those are the 2 soldiers, and then civilians here. Okay, that's one row. Now we look at the second row, 1, 1, 1, 1, and then a civilian. So this row is going to be stronger than this row. So far, this is like the weakest row. Okay, then we have 1, 0, 0, 0, 0. Okay, so now this is the weakest row. This is the second weakest row. This is the third. This is the third to weakest, meaning the strongest. Okay, so then we have 0, 0, 0, 0, 0. Okay, so this one is this case. So now I'm guessing, based off of what this is saying up here, this one's saying that this row is going to be stronger because its index is larger. Okay, and then this one is all soldiers, so it's the strongest row. This is a real strong row. Okay, so now, so K is 3, so we want the 3, return the indices of the K weakest rows. So we want the number 1 weakest, the number 2, and the number 3. So that should be this row, 0, 1, 2. Okay, yep. And then this row and this row are tied. So now they put the 0 indexed row as the second weakest, which is exactly what we said by this rule of the lower index is the weakest element on a tie. And then we have this index 3. Okay. Are these interesting, or are they just like, okay, not really interesting. So, okay. I guess what we were going to have to do to start off is go to Copilot and ask it for what are the methods available to me in the heap queue. I think it was called some strange library name or something. What are the functions available to me in Python for heaps? Okay. So then we're going to look at this. We're going to try to get these kind of in our head and then figure out, like, okay, well, how would we solve this problem given the methods and tools which we're being given right now with these heaps. So I remember heap is something to do with the largest, the k number largest or k number smallest elements in a group. So that's kind of the light bulb which we should be keying ourselves into, is whenever we hear k largest or k smallest, okay, we should be thinking about heaps. Okay, so here's heap queue. Okay, cool. So I can do just heap push, and then so I just create a list, and then I pass that list into this heap queue dot heap push, and then a number that I want. Okay. Okay, so then I can do heap pop, and that is going to be giving me the smallest element. So it returns back the smallest element when I do a heap pop. Now, I remember when we wanted to find the k largest, then what I would have to do is invert all of those things that I am like grading the heap on. And so then that way the largest number is actually the smallest number because it's negated and vice versa. And that way when you pop, you get the negative number, but it's actually the largest because it's the largest small. It's the highest value small number or negative number. Okay, so heap pop, heap replace, heapify. This is another good one. I don't think we actually need this one in our case because we're not just given a list of numbers. Maybe we do. This one is so you give it a list. Okay, so the input is a list full of those graded values, and then it will do an in-place operation in linear time. Okay, that's pretty nice. It's linear. Wow, okay. And, oh, so this one, it's linear time, and then I can pop, like, the element, and I can just kind of get the smallest elements that way. That's actually kind of cool. It's just linear, and it's linear and then O of 1, I believe, right? What is heap pop? Is it O of 1? It doesn't say the time complexity, but anyways. And then I can just do heap, okay, in largest, if I just want to return the largest values, like k largest values, I can do this in largest. That's cool. In smallest. These, okay, these are actually pretty cool. Nice. So now what are the tools available to us? So we just looked at this heap. And we saw that it takes in a list, and this list has integers in it, okay? And those integers are the grading, and it will like create this list, or then it will like do something, heapify this list, and then I can call a function to pop, and I get the lowest number. Okay. So, if I come here and I get the lowest number, each row, I count the number of ones that I get, and I store that in like the graded value. That's the graded value. I can do like a pop k times and get the smallest rows. But I'm not actually getting the rows, I'm just getting the number. So if my memory is recalling correctly, I think we had to use something like a dictionary where we had a key value, and I think that was it the key or the value is the graded variable that the heap uses. Okay. That's another question for here. So in a Python dictionary, is the key or the value the one which the heap queue will sort the by later. Okay. Okay, so does not directly sort dictionaries. Darn. Okay. However, you can use. Can I use like a tuple or something? However, you can use heap to sort dictionary items by either their key value by converting each item into a list of tuples. Oh, okay. Sure. Sure, I can use a tuple. Wait, hold on. Which one does it do for the tuple? Does it do the first or the second? I'm guessing the first index. To sort a dictionary by its keys, you can convert the dictionary item into lists of tuples and use heap q to create a heap based on the keys. Okay. I'm not going to use a dictionary in this problem here. I'm just gonna use a tuple. But I am kind of curious to see, okay, well, how do they actually uh, go about this operation that they're talking about? We have a dictionary, and we're gonna get the key and value, and then turn it into a tuple, and then I'm kind of curious how that process works. Okay. So let's see the code that it generated. All right, here we go. So this is a dictionary right here. So we have the dictionary. So the key is going to be like apple, and the value is going to be 3. Banana is key, 1 is the value. So cherry and 2. Okay, cool. So now we can do heap equals. Okay. You know, this is actually kind of funny because I remember when I was first learning heaps, like when I was doing it on NeetCode, not LeetCode, NeetCode, NeetCode. When I was doing it on NeetCode, I remember this syntax being wildly confusing for me, and I hated doing those conversions because I was like, I can't understand what is going on. I'm looking at this and I'm like, oh yeah, of course. Like, it's amazing how much you can learn and not even know that you are like passively taking stuff in. That's why I really like doing those random like coding projects and stuff like that, because you're doing something and you're trying to accomplish one thing, but actually you're learning so many other random things around you, and you're like, oh yeah, that makes sense. So I remember, like, why do I have these two random variables outside of a for loop, and then key and value is here, and then in this, okay, but then I'm putting this bracket around it. I had no idea why. Now I'm looking at it. Okay, heap is going to be a list. Okay, cool. Now, okay, I know that you can also do like a for, and then you say the value that you want. Like, this is the value that is going to be like returned each iteration over this iterable. So this is an iterable, and each iteration it is going to fill up this value. Okay, well, if there's 2 values, bam, bam, fills up 2. And now you can take this value and then put it out here. The expression outside of the for loop, that's kind of what is done each iteration. So what are we doing? We're just creating and what are these parentheses? They're a tuple. So that we create a tuple with what? The key of that iteration and the value of that iteration, and we put it in this list, which is going to be part of heap. So we just keep getting tuples each iteration, and we fill up this heap. Okay. The only thing that I didn't immediately know was this method that I'm allowed to use on a dictionary, which is .items. So, but looking at the context, it's pretty clear now what this .items does. It takes in, or it operates on a dictionary, and it returns the key value set, which we capture right here and then operate on right here. Okay, This, I remember this type of line was so confusing to me about 5 or 6 months ago. And I was like, what is going on? I don't get it. I don't get it. Now I look at it, I'm like, oh, okay, yeah, that's trivial. It's amazing like what consistent like practice does and just keep moving forward, right? It's also nice when you're not in school and it's not like, oh, do this assignment and you're just like focused on getting the assignment done. Now I'm at work and I'm like focused on getting my project done, right? Like projects, multiple. but now when I come home, I've dedicated time to practicing and it's kind of like I don't have a set goal anymore. It's not like finish the assignment, do the assignment. No, it's like learn. It's a very different feeling and goal and journey than when you're in school and it's just like do this assignment that accomplishes this, right? Like when I was in my machine learning classes, right? That was my first like real time that I used Python. And I didn't have time to be like, oh, I'm just so curious about all of these different things that are available to me. No, it was like survive. Like, how do you perform a gradient descent on a, a very large data set? And I'm using something called NumPy. I have no idea what that is. I don't know Python syntax. I don't know anything. And just like, so you have the concepts of like the machine learning and then you also have the concepts of like the brand new programming language just like thrown in. So you didn't have time to be like, oh, I'm just so, what's going on here? Anyways, oh, so we are back to this one. So then I just heapify that list. Yeah, that makes perfect sense. And then we're doing the exact same thing again. And so this like dash, not a dash, it's a underline or a dash is in the middle. This one's on the bottom. But anyways, this just means like remember what I said each time that so we do for something in and then this is an iterable and each time it returns a one of the elements in the iterable and then you're able to use this element to do an operation here which goes into this list. So if you see that little like underline thing, it just means like actually each time we do the iteration, I don't care about the value that I get. Just do this operation. And as you can see, this operation has nothing to do with this like variable that's returned each iteration. Okay, cool. So anyways, what are we doing here? We are going over, so length of heap. So we're just iterating through the heap, and so we're doing something number of heap times, or number of elements in this like list function. And then we're just popping them. Okay, so we have a list. Let's say it's of length 10. Okay, so we're going to iterate 10 times, right? This is going to return 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're doing that 10 times. We take that value, the 1, 2, 3, 4, and then we don't do anything with it. But each iteration, what do? We take this heap and we pop the smallest element. So that means that we are filling up this list, which is going to be equal to sorted by key. So we're filling up this list, and starting at the 0th index is going to be the smallest. The first index is going to be the second smallest. So each, all the way up to 9, which is the length of that heap. Not index 9 is going to be the largest element. So we're just filling up a list with the largest elements, and then we can just print that. Okay, cool. All right, so back to this. How long is this video? I don't know. My computer doesn't have a little timer on it or anything like telling me how long I've recorded so far, but we have not written a single line of code. Look down below and see how long it is. This is how long it's taken me even to get a single line of code on the page. All right, let's start writing some actual code now, okay? All right, so I just want to iterate over this matrix. So I am going to do like if not mat. So is M guaranteed to exist? No. But what is it? What does it want me to do in the case that there is no matrix? Is K guaranteed to be bigger than it here? Is K guaranteed to be smaller than M? Because if K is larger than M, we're trying to return 11 elements, but we only have 10 elements. That would be a problem. But here, K is guaranteed to be smaller than M, so we're good. So in the case that there is no matrix, we can actually just return and then just an empty list because it's guaranteed that K will also be 0 at that point because the length of M is 0, so K can only be 0. So we can just return an empty list right there. Okay. Now, what do I want to do? I want to iterate over matrix. Okay, so for row in range length mat. So now for item in range length mat this. Okay, so what do I want to do? I want to this row is going to indicate the index of the row that I'm operating at. And I want to store a list of tuples, right? So I want my tuple list. I don't know if it's a good name or not. It's not, but it'll do the trick. So now I'm going to put tuples inside of this list, and the tuple is going to have the first element as the like graded value, which would be the number of soldiers in the row. And then the second element is going to be the like identifier, which is the index of that specific row that I counted the soldiers. Okay, cool. So for item, so number of soldiers, SOLDIERS. Okay, cool. Equals 0. Just making sure that I didn't butcher the spelling. Okay. Anyway, so if matrix. So I'm going to check that row and then the specific column here. And I'm going to see if it is a soldier or a civilian. If it's a soldier, I'm going to increment this number. If it's not, I'm not going to increment the number. So, row, so that's the index of the row, and item. Maybe not a good name again, but it's fine. It'll do the trick. If it equals, and we said 1 is a soldier, so 1, then number of one. Okay, so just increment number of soldiers. Great. So we're going to do that for each of the elements in the row, so each of those columns in the row. And then once we finish going through all of them, I want to store that row's information in this list right here. So I'm going to go my tuple list dot append, and what do I want to append? I want to append, go like this, a tuple. Okay, so I'm appending something. What am I appending? A tuple. And what do I want? I want number of soldiers. That's the graded value. And then I want the row. So that's the identifier. This is the index of the row which has this many soldiers. Then I'm going to come back up to here, go to the next row. I'm going to reset number of soldiers to 0. I'm going to go through each of the columns in that row. I'm going to check if it's a soldier or not, and then I'm going to say, okay, if it is a soldier, then increment this by 1. Now, there we go. So now we have a list of tuples. Great. I want to find the k lowest. But I'm thinking back to this one. How do I make sure that a tie does not break this? I am not actually sure how I can ensure that a tie, because I'm not grading it based off of the row. I'm based off of the row value. I'm grading this based off the number of soldiers. Okay, I think I know what I'm going to do. I'm going to have to go through, like, pop off k number of times from my heap. So I'm going to heapify this list, and then I'm going to pop off k number of elements. Okay, then once I find those k number of elements, I'm going to take the second to last. No, that wouldn't work either. What I was thinking is I need to take the second, or the last element. So I take the last element, and then I look at its value, and then I pop one more time, and if I see that the value that I just popped off, so the threshold, if it's here's the last element here, and here is the element that would have been in the list, but is slightly bigger, right? Like it's right on the cutoff. If they're the same values, if they're a tie, then I need to swap the index which is lower. But that's actually not true, because what if we have the case where all of the numbers in the list are 5? Like all rows have 5 soldiers. All of a sudden I'm going to have 5, 5, 5, 5, 5, right? Like all of them have 5s. Then I get to the last element, and then I look over 1, and I say, oh, this one also has 5. So then I just swap them. No, because I actually need to base all of the numbers in my array based off of the row, which makes things immensely more difficult. You know, sometimes Python just works. I am going to try. I doubt this is gonna work. I highly doubt it. I'm like at maybe 6% confidence that this is gonna work. So 94%, I don't think so. But let's just try it. Let's see. Maybe this heap function looks at the first value and then grades it. Like if it's a tie, it just automatically grades this second one. Maybe. Who knows? Sometimes Python just works, and the logic is the same, right? Like the in lowest for soldier, okay, and then or the k lowest for soldier, okay, but the k lowest for row. So if they're a tie here, maybe you split it on the second index, and it's lowest for both of them, right? Lowest. So maybe it'll work. Maybe it'll work. Maybe not. Let us see if this will work. So I'm going to take my list of tuples. I feel the presence of an Amazon software development or SDE, software development engineer. I think she left. Anyways, I feel the presence. Okay, anyways, back to the problem. So I have a list of tuples. Okay, my tuple list. No, it was like the syntax was strange. It's like heap q dot heapify, and then I pass in the list. I think it is like my tuple list, and then it said that this was operated in place, so it changes this. So now I can just return, and then they had like in lowest or something, like heap q dot heap it, or in lowest, and you do k and my tuple list. So now this is a heap. Was that the general idea of that? In smallest 3, and then heap. Okay. In smallest. And okay, were the other ones correct though? It was what? Heap q. And I need to import heap q as well, but anyways, heap q dot heapify, and then you put in a list. Okay, cool. And then in heap q dot in smallest, number of elements that you want. Okay, cool. So let me just import that heap q. Is it here that I need to import, or up here that I need to? Heap q. Okay. Let's see. Wrong answer. 0 out of 52 passed. Oh, that's worse than I imagined. Oh, well, Yeah, okay, hold on. I So this is returning to me like 1, which is the graded value. There's 1 soldier in row 2. There's 2 soldiers in row 0. There's 2 soldiers in row 3. So, but it wants me to return the number of row. So like 2 was the row. 2, 0, 0, 3, 3. Okay, so I can't just immediately do a return statement here. So I need to collect a list. So answer equals a list. And now I am going to like do a heap pop. Now I get to show that cool syntax with the for loop, right? So I'm going to have some variable here that this is x right here is the variable that I want to add to my list called answer. Then I can do for and then something y in. And what do I want to iterate over? Okay, so I want to put in I want to keep getting the smallest values k times. Yes. Maybe this is not. Okay. It's much easier just to do it. For I don't know, what would it be? I in range length. No, in range of k. Yeah. So now a current element is going to equal heap q dot heap pop, and I pass in the heap that I created. So my tuple list. Okay, so this is going to return to me. Get rid of that. So this is going to return to me the lowest element, and I want to do this k times. So then I want to append my answers. So answer dot append, and I don't want to append both elements to this current. I only want to append the not the 0th index, but the number 1 index. So am I allowed to do something like current indexed at 1? And then I just return answer. Let's see if that. Oh. Do you guys remember when I said sometimes Python just works? This is what I mean. like, that's what I mean, man. It did. It took into account, okay, if they're a tie, it just graded on the second element. Oh my gosh. This is one amazing. Amazing. I love this. Anyways, thank you guys so much for watching this video. Yeah, I hope you guys had an amazing Christmas. If you like this video, consider subscribing. That would be awesome. My name is Timothy Lee Grant, and I will see you tomorrow. Thank you for joining this Christmas LeetCode grind session. Have a wonderful day.